I'm Alex Kripachka of Expedition 26 crew. You're watching NASA TV.
This is Mission Control Houston. We're inside the International Space Station Flight Control Room, where the team is monitoring systems aboard the space station and following along with the activities of the Expedition 26 crew. The team here is not working any major issues with the systems, just monitoring them and assisting with the activities on board as needed. The crew members are working through the early afternoon of their day. That includes NASA astronaut Scott Kelly, seen here inside the space station. He's the commander of the mission, and his colleagues, cosmonauts Alexander Kaleri and Oleg Skripochka, are elsewhere inside the space station. This afternoon, on board the station, the crew members have been working on some various maintenance and science experiment work. Kelly has been coordinating with the Japan Aerospace Exploration Agency, or JAXA, on some hardware configurations, adjusting the equipment that will be used when JAXA's next cargo vehicle arrives at the space station. There is a control panel inside the Japanese Kubo laboratory that Kelly set up last week that crew members could use to operate the automated vehicle called the HTV, which launches on an H2 vehicle, an H2B rocket. The HTV-2, as it's called, a nickname of Kanotori, or White Stork, is due to launch to the space station from the Tanegashima Space Center in January, on January 20th. And the crew members on board the station use the robotic arm, the Canadarm2, to latch on to the cargo vehicle and berth it to the station. It will be placed on the Earth-facing port of the Harmony node. So Kelly installed that panel and then has been doing checkouts of it this week.
Both of those cables are where you were expecting them to be.
Sounds great. Thanks for the additional task, Scott.
No problem.
Kelly's last few tasks with that work was to put away some of the equipment and cables that he had been using for those checkouts, and that panel has been checked out fine to support the cargo vehicle's arrival early next year. The cosmonauts aboard the space station are scheduled in the afternoon to work for a few hours with a science experiment called BAR. It is using instruments on board, studying the development of methods and instruments to detect the location of a loss of pressurization of a module on board the space station to help perfect that technique in the future. The crew members have about 6.5 hours left in their day today, including the rest of that experiment work by the cosmonauts and some exercise routines for all the crew members to stay in good shape while living on board the space station, and a daily planning conference before going into their pre-sleep period to get ready to go to bed about 3:30 p.m. Central Time. Before that, the crew members will still be awake for the launch of the Soyuz vehicle this afternoon. That is due to launch at 1:09 p.m. Central Time. That launch will be shown here on NASA television beginning at 12:15 p.m. Central Time, 1:15 p.m. Eastern. There will be a video coming through from the Baikonur Cosmodrome before that, showing the crew members' activities leading up to launch. That starts at 11:30 a.m. Central Time. The crew members launching on the Soyuz are Soyuz Commander Dmitry Kondratyev and flight engineers Paulo Nespoli and Katie Coleman.
Number 8.
Copy, SSC number 8. Thank you.
The crew members are scheduled to get suited up at about 8:49 a.m. Central Time this morning. Then report to the State Commission about 9:59 a.m. Central Time and depart for the launch pad at 10:04 a.m. The crew members would then arrive at the launch pad about 10:34 a.m. Central Time and board the Soyuz a few minutes later and be in the vehicle about 11:09 a.m. Central Time. At 11:39 a.m., the hatch will be closed and leak checks begin. And shortly thereafter, our NASA television launch coverage begins about 12:15 p.m. Central Time to continue the updates of the operations leading up to the launch. With launch scheduled at 1:09 p.m. Central Time, that is 1:09 in the morning at the Baikonur Cosmodrome in Kazakhstan on Thursday already. With that launch, the Soyuz then would be on its way to the International Space Station due to link up with the complex on Friday. The docking is scheduled for 2:12 p.m. Central Time, and that too will be shown here on NASA television. That coverage begins at 1:30 p.m. Central. There will be communications with the space station allowing the video uplink of the Soyuz launch to the space station crew. And then after that, the crew members again are scheduled to go get ready to go to sleep at about 3:30 p.m. The crew members aboard the station were busy with other activities throughout their morning aboard the complex. They awakened about midnight Central Time, working with other experiments, including a Russian typology experiment, which is studying how different crew members perform different tasks during a long-duration mission. What astronaut Scott Kelly worked on during his morning aboard the space station was a science experiment that has been tailored to involve high school students here on the ground. The bowling ball-sized spherical satellites that have been on board the space station for a while now have been adjusted and managed by MIT to include participation by students The experiment is called SPHERES, which stands for the Synchronized Position, Hold, Engage, Reorient Experimental Satellites. They have been tested on board the space station to help understand the performance of autonomous rendezvous and docking maneuvers. It includes 3 free-flying spheres that fly within the cabin of the space station. It has been in operation since Expedition 13, when 1 sphere was just used initially. And then the second and third satellites were delivered on later missions to incorporate the full set. And then since Expedition 21, the high school students have been involved. And the sessions have been recalled the Spheres Zero Robotics program that enables students from middle school to college levels to participate in programming and designing tools for the spheres on board the station. It's a software design competition that allows the students to run their algorithms aboard the station. For this particular session, from September to this month, 24 teams competed in online competitions and ground testing at MIT, and 10 finalist teams advanced to the final competition. The program culminates with this tournament test session, which will actually occur on Thursday. But astronaut Scott Kelly used time this morning to set up the video equipment to monitor that activity and do a dry run of the operations of the spheres. We do have some video that was recorded during that activity earlier today that we can show here on NASA television. Here we see astronaut Scott Kelly inside the Japanese Kibo laboratory. The 10 teams that are involved in this session are from states across the U.S. They were given a challenge that is a scenario involving a program to build a solar-powered spacecraft in low Earth orbit. That construction had encountered some problems, and then the students' challenge is to use the spheres to find the solar panel and help move it to the construction site.
I'm still on 2 for the quick check out.
Consultation on 2.
Yeah, it's still running. But,
During the competition on Thursday, the first team to complete the 3 phases of the game will win. That includes finding the virtual solar panel, flying to the panel, and docking to it by aligning the sphere's Velcro face in a specific orientation, and then return the panel to a virtual station or the construction site and dock by again aligning the Velcro face of the sphere along a specific wall inside the station. If no teams are able to dock to the station by bringing the virtual panel, back to the designated area. The team that stays docked to the panel the longest could win, or that found the panel first, or got closest to the panel if nobody is able to actually attach to the panel.
So you mean taking the GUI, test control GUI to stop, and then power cycling the blue satellite?
This is video recorded earlier on board the space station with NASA astronaut Scott Kelly going through a dry run with the spheres in preparation for the student competition Thursday morning. That competition is scheduled to take place around 8 a.m. Central Time aboard the space station, and then that is before the ISS update for the day, but the update at 10 a.m. Central Time could include information about how the competition went.
Blue satellite still has no comm.
And Scott, can you check the battery power on the blue satellite?
Well, like I said, it was low. It's still low.
And Scott, we are good if you could change the battery to a good battery.
Okay, in the blue satellite, change both batteries to good batteries.
Yeah, and those can be new batteries.
Copy.
Kelly is coordinating the work on the Sphere's Zero Robotics activity with the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, which coordinates all of the experiments with the crew members in the U.S. operating segment, along with the other control centers around the world that support the European Space Agency's Columbus Laboratory and the Japanese Kibo Laboratory.
Huntsville, put in new batteries. Blue has a low battery light, and those were new batteries, new good batteries. The enable light on blue is solid. The enable light on red is flashing. No comm on red. Battery low light on red is not illuminated.
And Scott, we copy. Stand by just a second.
This is Mission Control Houston, continuing to watch video recorded earlier aboard the space station.
The blue, I pushed on the battery some, and the low battery light went out.
We copy.
NASA astronaut Scott Kelly was going through a setup procedure and dry run of operating the Sphere's satellites aboard the station.
Red still has enable LED flashing.
Okay, Scott, if you could reset the red one and see if that enable light stops flashing.
The work today is the setup for the actual competition of high school students using the satellites aboard the station Thursday. It's part of the Sphere's Zero Robotics program. SPHERE stands for Synchronized Position Hold, Engage, Reorient Experimental Satellites. They're the bowling ball-sized satellites that are on board the station. There are 3 that are used for an experiment that was developed by Dr. David Miller at MIT and has been in operation aboard the station since Expedition 13. The first satellite arrived in 2003 and then was used during Expedition 13 in 2006, and then the second and third satellites were added. The experiment by MIT is used to test a set of well-defined instructions for a spacecraft performing autonomous rendezvous and docking maneuvers. Each satellite is self-contained with power, propulsion, computers, and navigation equipment. And the principal investigator believes the results are important for satellite servicing, vehicle assembly, and formation flying spacecraft configurations. Beginning with Expedition 21 in 2009, the satellites were incorporated into this opportunity for high school students and college students to participate in competitions.
1 and red a 52.
We copy.
Hey, let me know where you want to proceed next.
The competition is a software design competition that allows the students to run their algorithms with the satellites aboard the station. For this particular session that will be operated on Thursday, students
Move on to Test A, Race A, and Competition Bracket 1.
For this session Thursday, students competed from September to December in online competitions. There were 24 teams, and then went through ground testing with the Spheres team at MIT.
The option of test numbers. Which one should I select?
And Scott, we need you to select Team 8 versus.
Okay, the one that says Team 8 versus ... which is number 9.
Correct.
In preparation for the competition Thursday morning, astronaut Scott Kelly went through a dry run of some of the setups to ensure the satellites and systems are ready to support the competition. There are 10 teams that made the finals for this competition from different states around the country. That includes Friendswood High School from Texas, the Cypress High School and Granite School District from Utah, the Lexington Christian Academy in Massachusetts, Glenbrook North in Illinois, the Prince William County School System in Virginia, the Upper St. Clair School District in Pennsylvania, the Stuyvesant High School in New York, the Charlottesville High School in Virginia, the Falmouth High School in Maine, and Naples High School in Florida. This is a video recorded earlier today when Kelly was going through the setup procedures.
I didn't hit number 9 fast enough.
Copy.
This is Mission Control Houston. Again, this is video that was recorded earlier aboard the space station with the setup and dry run for the student competition using the Spheres equipment on board the station Thursday morning. The scenario for the students that they needed to develop the algorithms for included a company that is building the first space-based solar array. And while construction of that was underway, there was a problem, and the students are using the Spheres satellites to find a panel, the solar panel that has come away from the construction site, and then the satellites would be told to dock to the panel and then bring it back to the station where the solar panel is, or solar array would be constructed. Those are the 3 steps in the competition to judge what team is successful. First, finding the virtual panel, and then docking to it by aligning a specific side of the sphere in a specific orientation, and then moving it to a different area to simulate returning the panel to a virtual station, and docking by aligning the sphere again to a specific face of a wall on the station, inside the station. This is now a view inside the space station with NASA astronaut Scott Kelly, who is now working through his mid-afternoon aboard the station after having done that setup and dry run of the Spheres procedures earlier in the morning. Kelly is scheduled to be participating in some of his exercise routine, working out on the advanced resistive exercise device, which simulates weightlifting in space, which Kelly actually performed some maintenance on that exercise machine earlier in the week to help it perform better. And he's also scheduled to exercise on one of the treadmills aboard the station. While Kelly is working inside the Destiny lab here, his colleagues, cosmonauts Alexander Clary and Oleg Skripochka, are scheduled to be working with a science experiment in the Russian segment that involves the choice and development of methods and instruments to detect the location of a loss of pressurization of a module aboard the space station to help perfect that technique. Before the crew members on board the International Space Station go to sleep this afternoon, they will be able to watch the launch of their new crewmates. Soyuz Commander Dmitry Kondratyev and European Space Agency astronaut Paulo Nespoli and NASA astronaut Katie Coleman. They are due to launch to the space station at 1:09 p.m. Central Time, which is 1:09 in the morning Thursday in Kazakhstan. Those three crew members will be joining up with Kelly, Kaleri, and Skripochka on Friday, with the Soyuz docking to the station scheduled for 2:12 p.m. Central Time. The current station residents, Kelly, Kaleri, and Skripochka, just have a few hours left in their day, having completed science experiments and maintenance work throughout the day. We do have a short video that describes those crew members and introduces you to them a little more, and we'll show that here on NASA television now.
The three men now on board the International Space Station started this flight with more than a year and a half of spaceflight experience among them, even though one is a first-time flyer and another had spent 3 weeks on orbit. U.S. Navy Captain Scott Kelly was born in Orange, New Jersey, a year before the first Gemini mission. As a boy growing up in nearby West Orange, he remembered the first moon landing, but being an astronaut wasn't exactly high on his agenda.
When I was a kid, I was interested in being an astronaut, like a lot of kids are interested in being an astronaut because it seems like an exciting job. You know, I was also interested in playing baseball for the Mets and, you know, race car driver, and other more realistic things, I think, as I got older.
The realistic occupation that eventually grabbed Kelly's attention was flying for the military. And not just any old fighter pilot job would do.
I chose the Navy over the Air Force because I thought landing on the ship would be harder and more challenging than landing on a runway, and I was right.
So he joined the Naval ROTC at the State University of New York Maritime College and earned a Bachelor of Science in Electrical Engineering. After pilot training and a few years of overseas deployment in a fighter squadron, Kelly was selected for the Navy Test Pilot School, and then earned a master's in aviation systems from the University of Tennessee in 1996, the same year he was selected as an astronaut, in the same class with his twin brother, Mark. Kelly was the pilot on the 1999 Hubble Space Telescope servicing mission, commanded the 2007 shuttle flight that delivered the International Space Station's S5 truss segment, and sees this flight as the next challenge.
Basically, we fly in space to see if we can fly in space longer, and if we want to venture away from our planet, we need to know how to do that. But then there's also the medical research we can do on board, the material science, other types of basic science that are equally, in my opinion, important.
Flight engineer Alexander Kaleri is one of the most experienced space travelers in history and should finish this flight ranked second for the most time spent on orbit. He was born and raised in Jurmala, a seaside town near the capital of Latvia, and Yuri Gagarin's spaceflight is the only one he doesn't remember.
In August of 1961, then German Titov flew. It was the second flight, a one-day flight on board Vostok 2. So I can remember this flight very well. And I was 5. And I can say that then I was 7 or 8. I have no doubts then I'll be a cosmonaut.
Kaleri was influenced by his father, a navigator and paratrooper who became an engineer in civilian life, and counseled his son that it might be more interesting to design spacecraft and fly them rather than just be a pilot.
At the end of high school, I looked through the list of institutes in the Soviet Union. It was a thick book. And I saw one institute in Moscow, Moscow Institute of Physics and Technology, and one of departments was called Department of Aerophysics and Space Research. And I thought, oh, it's for me.
Kaleri finished his degree at the Institute on a project with the Korolev Design Bureau, the forerunner of the spacecraft designer now known as the Rocket Space Corporation Energia. He went to work for Energia right out of college, developing design and test documentation for the Mir space station, and was selected as a cosmonaut of Energia in 1984. He made his first trip to space as flight engineer on Mir 11. During Mir 22, he was a crewmate to 3 American astronauts during the Shuttle Mir program and was on board to fight the fire on that station in February 1997. Kaleri was on the Mir 28 crew that prepared the Russian station for deorbiting and was flight engineer on the International Space Station's Expedition 8 crew in 2003 and 2004, compiling 610 days on orbit on those 4 space flights. Why does he do what he does?
How to explain the necessity of going behind the horizon? It's very human quality. So it's maybe most valuable frontier for humankind. Space flights and going into space and to the low or Earth orbit and into the deep space.
Flight engineer Oleg Skripochka was born in the city of Nevenomysk in the Stavropol region in the North Caucasus. His father's military career meant moves to many locations, including Russia's far eastern Kamchatka Peninsula, before finally settling in the city of Zaporozhye in southeastern Ukraine. As a young boy, Skripochka wanted to be an officer, like his father.
Then my plans changed. And then probably in the 9th grade, I was about 15 years old, I happened to hear from a classmate that we do have an organization that prepares future cosmonauts.
Skripochka talked his way into this young cosmonaut school, where lessons in skydiving and scuba were just a part of the curriculum.
I took classes on cosmonautics, on the hardware and technologies that is used in space, also just a general philosophical issues such as why we're doing this and where we want to go from here.
When he traveled to Moscow as part of the school's team for the Korolev reading competition, he was introduced to the Bauman Moscow State Technical University and cemented his choice of college. Skripochka earned his degree in mechanical engineering at Bauman while working at RSC Energia as a metal worker and technician. He became a design engineer after graduation and was selected as an Energia cosmonaut in 1997.
So I think that it's just an inherent nature of a human being to expand, to research. Earth is the cradle of our civilization, but it is possible right now it's not the best time for us, but I think it's temporary, and we will move forward and move beyond our planet and continue developing our civilization.
This is Mission Control Houston inside the International Space Station Flight Control Room, where the team is monitoring systems aboard the spacecraft and following along with the activities of the Expedition 26 crew members. That includes NASA astronaut Scott Kelly, who is currently the commander of the station, and his colleagues, cosmonauts Alexander Kaleri and Oleg Skripochka. Those crew members have been working on various science experiments and maintenance activities today. Kelly spent a big portion of his morning setting up and testing out the procedures for a Spheres Zero Robotics competition that involves high school students and will be operated aboard the space station Thursday morning. That involves the 3 bowling ball-sized satellites aboard the station that are being used by the developers at MIT to test out autonomous rendezvous and docking maneuvers, and recently, a few years ago, was also incorporated into an educational outreach opportunity for high school and college students where they developed the actual software. There were teams that competed online and in ground testing at MIT, and down selected to 10 teams that are participating in the onboard experiment Thursday morning. Kaleri and Skripochka worked with an experiment throughout the afternoon of their day that is focusing on the choice and development of methods and instruments that would detect the location of a loss of pressure from a module on board the space station to help refine those techniques. They also performed a test of the video downlink system that will be used through the Ku-band antenna during Friday's docking of the Soyuz spacecraft to the space station. That Soyuz is scheduled to launch from the Baikonur Cosmodrome at 1:09 p.m. Central Time today to make its way towards the International Space Station with the new crew members, Soyuz Commander Dmitry Kondratyev and European Space Agency astronaut Paulo Nespoli and NASA astronaut Katie Coleman. The 3 crew members are scheduled to dock to the space station Friday afternoon at 2:12 p.m. Central Time, and that docking will air here on NASA television, with that scheduled to begin at 1:30 p.m. Central Time. The team here in Mission Control is not working any issues with systems, just monitoring the performance of all of the space station systems and following along with the activities of the crew members. The team here in Houston will also monitor the launch of the Soyuz, which will be watched closely by the team in Moscow, the mission control team that is situated in Korolev, just outside of Moscow. The Soyuz crew members are getting ready for their launch to the space station in the early morning hours, Kazakhstan time, Thursday morning. The cruise was due to suit up at 8:49 a.m. Central Time today and report to the State Commission about 9:59 a.m. and then depart for the launch pad about 10:04 a.m., arriving about 30 minutes later to climb the stairs towards their Soyuz vehicle and be inside the vehicle by 11:09 a.m. Central Time. Hatch would be closed then at 11:39 a.m. And then about 12:15 p.m. is when our NASA television coverage of the launch begins. NASA astronaut Scott Kelly aboard the space station had requested earlier that the video of the launch be sent up to the station so that the crew members could watch their counterparts launch to the station. That is made possible through the Ku-band antenna system that allows video communications between the space station and mission control. Again, the launch coverage today is scheduled to begin at 12:15 p.m. Central Time for that 1:09 p.m. Central launch. And all the video highlights of today's activities will air in video file at 4 p.m. Central Time. The ISS update will be as scheduled Thursday morning at 10 a.m. Central Time. The Spheres Zero Robotics competition is scheduled to occur before the ISS update. So any information from that competition could be shared in the update Thursday morning. The crew members on the station then have some time to make final preparations for the arrival of their crewmates on Friday afternoon. This is Mission Control Houston. The team here is continuing to monitor systems aboard the station. The team is led by Flight Director Kwatsi Alibarujo, is seen to the right of the screen, and seated next to him is astronaut Ricky Arnold, who is serving as the spacecraft communicator, or CAPCOM, today to speak with the crew members aboard the station. The team will continue to work with the crew members aboard the complex and monitor the launch of the next set of crew members this afternoon. Again, the launch coverage is scheduled to start at 12:15 p.m. Central Time. And ISS update will air as usual Thursday morning at 10 a.m. Central Time. Before launch coverage begins today, there is time to watch video coming in of the activities so far for the crew members preparing for launch. That is scheduled to come in at about 11:30 p.m. or 11:30 a.m. Central Time. All preparations are going well for the launch of the Soyuz TMA-20 vehicle from the Baikonur Cosmodrome in Kazakhstan. For now, this is Mission Control Houston.